Now, what about independent events? This will almost definitely be something new that you haven't heard about before. So independent events have no effect on each other. So a good example of this is throwing a dice. So if I throw a dice and get a 6 on the first throw, when I throw it again the second time, there's no difference in the probability of me getting a 6 because I rolled a 6 on the previous go. Okay, they're independent events. The probability of getting a 6 is always a 6. It doesn't matter what I rolled on the previous go. Okay, they're completely independent events. The dice has no memory of what it rolled last time, what number it got last time. Okay, so that's an example of independent events. Throwing a coin, tossing a coin is another example. It always lands on heads 50% of the time. Just because I got 9 heads in a row doesn't mean it's more likely that I'm going to get tails. It's always the same probability regardless of what happened on the previous roll. Okay, so then examples of independent events. An example of something that might not be an independent event is something like the probability that the probability that it rains on Saturday and the probability that it rains on Sunday. Okay, they're not independent because say there's a storm and it rains in multiple days in a row, the probability of it raining on Sunday is affected by whether it rained on Saturday. Okay, so that's an example of two events which aren't independent. If it rained on Saturday, it's probably more likely to rain on Sunday as well. And if it didn't rain on Saturday, it's probably more likely it's not going to rain on Sunday either. Okay, so they're not independent events. And that's what in this section is all about, whether events have independence or not. There's a way of checking mathematically whether they're independent. We work out the probability of A and the probability of B. If that's equal to the probability of A and B, then the events are independent. I'll show you an example here. Here's a Venn diagram for us to look at. Now, the probability of A, remember that's everybody inside A, so it's these people and these people. So that's 0.45. The probability of B is everyone inside B, so it's these people and these people, that's 0.6. The probability of A and B are just the people in the overlap between the two events, so that's just a 0.1. Now, if they're independent, that means that 0.45 times 0.6 should equal 0.1. But it doesn't, does it? If we put that in the calculator, we get 0.27. So actually, it doesn't equal 0.1. So these are not independent because that equation doesn't work. That equation only works if events are independent. So these two events are not independent, okay? Because a 0.45 times a 0.6 doesn't make the probability of A and B. It actually gives us a completely different number. Okay, so that's an example of not independent events. What about these ones though? Let's work it out again. So the probability of A for this one is the 0.42 plus the 0.28, everyone inside A. That's 0.7. The probability of B are the 0.28 plus the 0.12, which is 0.4. And the probability of A and B are the people in the overlap. That's 0.28. So if I do the probability of A times the probability of B, I get 0.7 times 0.4, which is 0.28, isn't it? Yeah. So these two are independent because 0.7 times 0.4 is 0.8. Okay, if this equation up here works, then they're independent. So they are independent. Okay. So these are two events which have no effect on each other. The outcome of one does not affect the outcome of another one. So there's lots of things which aren't, or it's quite difficult to tell if they're independent. For instance, an example in school might be the probability of someone studying physics and the probability of someone studying chemistry. They're probably not independent because someone who studies physics is probably also quite likely to study chemistry because it tends to be things that are often, not always, but quite often studied together. So some subjects, they do have an effect on each other and they tend to study them together. It's the same with things like maths and physics. They tend to be studied together, so they're not independent events. It's more idealized things like rolling a dice or tossing a coin that do tend to be independent events.